Hello students, in today's video we will discuss some rules for the determination of oxidation number of an atom in a molecule, or in other words we can say to calculate the oxidation number of an element in a compound. So for those, first rule says the oxidation number of an element in the free or elementary state or in any of its allotropic form is always taken as 0. For example, elements like helium, hydrogen, oxygen, if we consider its atomic form in the molecule, then its oxidation state or oxidation number will always be 0. For example, oxygen. Oxygen atom in oxygen molecule or in ozone molecule O3, elemental oxygen will always have its oxidation number 0. In second rule, the oxidation number of an element in a single ion or monoatomic ion is the same as the charge on the ion. For example, in potassium cation, we have single positive charge, so we can say the oxidation number of potassium ion is +1. For calcium ion, calcium is having +2 charge, so oxidation number of calcium ion is +2. Similarly, for aluminium, aluminium is +3 in charge, so oxidation number of aluminium is +3. According to the third rule, in binary compounds made up of metal and non-metal, the oxidation number of metal is always positive, while that of non-metal is negative. For example, we consider a molecule NaCl, sodium chloride. It is made up of sodium and chloride. Sodium is metal and chlorine is non-metal. We can say, according to this rule, oxidation number of metal, that is sodium, is +1 and non-metal is -. So, oxidation number of chlorine is -1. Now, according to fourth rule, in compounds that are formed by the combination of non-metallic atoms, the atoms with a higher electronegativity is given negative oxidation number. For example, hydrochloric acid, HCl, hydrogen and chlorine both are non-metals. So, out of these, we will take the most electronegative atom as negative oxidation state. Chlorine is more electronegative, so oxidation state of chlorine is -1, negative. Similarly, for hydrogen, it will be +1. Similarly, in ammonia, NH3 and Ni3, oxidation number of or oxidation state of ammonia is -3 because nitrogen is more electronegative than hydrogen and iodine. In NCl3, see, in both of these atoms, nitrogen is less electronegative than chlorine. So, negative atomic number will be for chlorine and oxidation number of nitrogen will be +3 then. In the fifth rule, all the compounds of hydrogens, oxidation number of hydrogen is +1 except for the hydrides like lithium hydride, sodium hydride. In these cases, oxidation number of hydrogen is -1. Coming to the rule number 6, in the compounds containing oxygen, oxidation number of oxygen is -2 in case of oxides, but in case of peroxides, oxidation number of oxygen is -1. The seventh rule says the most electronegative element, fluorine, has oxidation number of -1. Also for other halogens, oxidation number will be -1, but when they are bonded to more electronegative halogen, exceptions will be there. For example, IF5, both are halogens. Oxidation number of fluorine is -1 because fluorine is more electronegative than iodine. So, oxidation number of iodine will be +5. In simpler case, hydrogen iodide. Here, iodine is more electronegative than hydrogen. So, negative oxidation number corresponds to iodine, but oxidation number of hydrogen will be +1 here. In another example, IF7, fluorine is more electronegative, so oxidation number of fluorine will be -1 and oxidation number of iodine will be +7. Now, for the last rule discussed, if there is a molecule which is neutral, so Rule says the sum of oxidation number of all the atoms in the molecule is equal to 0 because there is no charge on the whole molecule. Example is sulfuric acid H2SO4. Hydrogen is having +1 individually. So there are 2 atoms of hydrogen that will correspond to +2, plus 6 oxidation state of sulfur, and -2 for 1 atom of oxygen. So there are 4 atoms of oxygen that corresponds to -8. So if we add up oxidation states of all these atoms, that corresponds to 0. Similarly, for a complex ion, means the molecule is having some charge onto that. In that case, sum of oxidation numbers of all the atoms is equal to the charge of the whole ion. For example, we have sulfate ion, SO4 2 negative. We can see that there are sulfur atom, oxygen atom, but as a whole there is a charge of -2. So if we add up oxidation numbers of all the atoms, that should be equal to -2. That is, sum of oxidation number of sulfur and oxygen, that should be equal to the charge of the molecule, that is -2. So one thing we must clear, that oxidation number is also called oxidation state, or in other words we can say that oxidation number gives the oxidation state of the element in a compound. Now we will discuss some examples following all these rules in the next section.